Hi. This time we're given a list of numbers and we are going to check if it fits into this pattern where we have a non-decreasing segment followed by a non-increasing segment. This might sound backwards to say non-decreasing, non-increasing, but that I don't really want to say increasing and then decreasing because plateaus are fine. It's okay if the value stays the same as long as it's not going the opposite direction. Okay, how are we going to do this? Let's have an example of something that does go up and then down again. Okay, this is very simple. And a very neat way of doing it is by doing a normalization, we could say, do a transformation of this list such that it will only stay the way it is if it abides by the rules. And if there are any breaks to the rules, then it will be changed. And then we can compare the original list with the modified one. If they're the same, then it abides by the rules, and if not, then it doesn't abide by the rules. Okay, we're going to do this tacit from the outset. That means we're only applying functions and never mentioning our argument by name. And so the trick here that we're going to use is we're going to do a maximum scan. So the maximum function is a function that takes two arguments and returns the larger of them. And we're going to insert it between the elements here, but over the prefixes. So we're going to insert it, first we're going to have just 1, and then do 1 and 2, that gives 2. Then 2 and 3, that gives 3. Then 2, 3, 4, or 1, 2, 3, 4, actually, and that gives us 4. 1, 2, 3, 4, 5 gives us 5. 1, 2, 3, 4, 5, 3. Now the maximum that we have seen is 5, which means that the corresponding element of the result to 3 will be 5, and the same thing goes for 1. So we can try this. This is a maximum scan. So here we can see that after we hit the highest value, we don't go down again. And this is a nice way of expressing the idea of being non-decreasing. What about the other way? What if we're going to start from the right and do the same thing? That means after we hit the highest point, we stay with the highest point going left. Well, we don't have a scan from the right, but we can pre-process the scan argument with a reversal function. So now we reversed the argument 1, 3, 5, 4, 3, 2, 1, and then we did the scan, and that gave us the 1, 3, 5, 5, 5, 5. Now we just need to turn it around back to its original order, and here we have a scan from the right. Okay. How can we combine these two? Because we want to preserve the array the way it is if it abides by the rules. There are two parts to this. But for this particular problem, we can combine them by taking the minimum value. If we now compare this list here and that list there, then the minimum of 1 and 5, that's 1. The minimum of 2 and 5 is 2. 3 and 5, 4 and 5, up until they meet. And then we go down on the other side. The minimum was now going to be down here. That's the 3 and the 1. So we take another maximum scan, which is the one that goes from left to right. And this is the scan that goes from right to left. And we take the minimum of the two. But the pattern here that for tested functions is that an outer function is applied and the inner function is applied to the results of the outer functions. So that pattern is broken if we try to put the reverse function in here. This should be the inner function altogether. But notice the pattern here is very much like this, where we want to pre-process the right argument with a reversal. So pre-process the right argument with a reversal, That's this operator. And that gives us back the original array. Now, let's try if this indeed holds if we make any modifications. So here after the end, we go back up again. And we can see that the 3 and the 1 and the 4 got smeared out, so to say, by the 4 coming in from the right when we are doing the scan, the maximum scan from the right. We get 4, 4, 4, and then 5. And we go from the left, we get 3, 4, 5, 5, 5, 5. And then we take the minimum of the 2. That's going to be the 4 that came from here. And that means that there's a difference there. We can also try doing it with a value in the middle. We can see that kind of got painted over by the 3 from the right and the 4 from the left, and therefore it became a 3, the minimum value. What if we turned the whole thing upside down? Here, the 5 coming in from the left with a maximum scan paints over 5s until we get to a larger value. And the 7 makes 7s all the way to the left. The minimum of that is going to be all the 5s with a single 7. So this looks good. Now the only step that's missing is that we compare this to the original argument. So we need to do a comparison of all the elements together in one go with the original value, which we can represent with the identity function applied here. So the way this executes and binds is every other function is applied to the argument, and the intervening functions are applied between those results. So we do the scan from the right in the reverse, we do the scan from the left, and then we do the minimum of those two, but reordering the right side to become its original order. And the result of this is compared to the result of the identity function, which is the original argument. And so this doesn't hold. But if we did something like this, then it does hold. And in fact, we don't even need this many spaces. We can remove all of that, save some horizontal screen estate. This works very nicely. Thank you for watching.